Domain and range. Definition. In the last video, we briefly talked about domain and range. Let's use formal definition here. The word domain refers to the set of all values of the first coordinate or the independent variable of the ordered pairs in a relation. The word range refers to the set of all values of the second coordinate or the dependent variable of the ordered pairs in a relation. Recall that relations can be represented in different ways. In the last video, we talked about how to represent them using a set of ordered pairs and a mapping diagram. So we're going to look at what happens when we have table values, graph, and equation. We're not going to focus in words right now because that's just a word problem. So let's look at some examples. Let's review what to do with a set of ordered pairs. For the relation 6, -3, 6, 2, 6, 5, and the last point is 6, 8. Determine if it is a function, and then state the domain and range. So how do we determine if a set of ordered pair is a function again? We check the x-coordinate. Since the number 6 is found in the first coordinate 4 times, this relation is not a function. Okay, based on our last video, it means we have a master key that can open 4 different doors. So this is not a function. The domain is just 6. The range, we have -3, 2, 5, and 8. Remember that we have to line up the numbers in ascending order. So from smallest to largest. Another way to write them, okay, the formal way of writing your domain and range is as such. Okay, so we have x belongs to the set where x is 6. And y belongs to the set such that y is -3, 2, 5, or 8. Example 3, table of values. We're going to check if this is a function or not, and also we're going to state the domain and range. First, we want to check the x column. Okay, it is a function because nothing is repeated in the column for x. This means that I have 4 different keys and I can open 4 different doors. Next, for the domain, we have -6, -4, 0, and 3. For the range, we have to list them in ascending order, so it's 1, 2, 3, and 4. Please do not write 3, 1, 4, 2. That's the wrong order. Since the values in the range are in an interval, we can rewrite the range as y belongs to a set of natural numbers and y is between 1 and 4 inclusive. Example 4, let's start looking at graphs. We're still checking if we have a function or not, and then we want to state the domain and range. When we're given a graph, we want to use a vertical line to check if it is a function or not. So first we have a vertical line. We're going to slide it across the graph. As we do that, we can see if the vertical line passes through one or more points on the graph. So on this particular graph, we have 1 point that being passed through, 1 point, passing through 1 point, passing through 1 point, again, 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 and again. we have the vertical line passing through them just once. So it is a function according to the vertical line test. For the domain, we notice that x started at -3 and stopped at 5, and then it goes up by an interval of 1. So we start from -3, we had -2, -1, 0, 1, 2, 3, 4, 5. Now we're not sure if we have more points than what we can see with our naked eyes. So for the purpose of practicing, we'll just assume that we're going to leave out anything that we can't really see outside of the grid. We're not going to assume that the graph continues forever because there's no indication on the graph that says so. Because the domain is within an interval, we can rewrite it as x being in a set of integers. Okay, remember that set stands for integers. We do not use the letter I. And x is between -3 and 5 inclusive. For the range, we notice that the parabola has a minimum value at -1. And then the maximum value that we can see is 4 on the graph. However, the points in the middle, they are all different. Some are repeated, but they have different numbers, and we even have decimals. So when we read them carefully, these are the values that we have. The range, we started from -1, and then we have -0.8, -0.1, 0.9, 2.2, and 4. You might argue that -0.8 looks like -0.9 or -0.7 to you, and someone might say it's actually -0.7778. As this number is just an estimate based on what we see with our eyes, it's okay to have -0.8 or -0.7 or -0.9, as long as we agree that it is not a -1 and definitely not a -0.5 either. We can also write the range formally as such, okay, saying that y belongs to the set of numbers such that y equals to -1, -0.8, -0.1, 0.9, 2.2, and 4. Why is it wrong for me to say that y belongs to the integer set and y is between -1 and 4 inclusive? Why is it also wrong to say that y belongs to the real number set and y is between -1 and 4 inclusive? So think about this. Example 5. Let's look at another graph. Since this is a graph, we want to use the vertical line test to check if it is a function or not. So first, we construct or draw a vertical line, and we slide it over and check if it is passing through only one point on the curve at all times. So let's slow down a little bit, and let's say we stop the time and we look at the curve and the vertical line at this point. So we notice that the vertical line is passing through the curve at only one point. If we slide the vertical line back and forth to check, we would notice that it doesn't matter where the vertical line is located, it is always only passing through one point on the curve. It cannot pass through more than one point at a time. So therefore, this relation is a function. For the domain, since the curve is going on forever because it goes all the way to the edge of the picture, and then it keeps on going. It doesn't stop at the grid. So the domain is that x belongs to the real number set. And if we write it formally, this is what it looks like. For the range, we have a minimum value of -2, and then there is no restriction to the maximum value of the range. So y belongs to the real number set, and y has to be greater than or equal to -2. If we write it formally, this is what it looks like. Let's look at one more graph example. This time we still have a parabola, but it's sideways. So let's run our vertical line test to check. So I have my vertical line. I'm going to scan it over. You would notice that the vertical line is passing through the curve twice at most of the spots. Okay. Besides the vertex, the vertical line passes through exactly 2 points, okay, of the curve. So therefore, it is not a function. Now the domain. So the smallest value for the x-coordinates is -4. And then as we go towards the right, x can go towards infinity, so it will go on forever. So x must be greater than or equal to -4. So that's our domain. So x belongs to the real number set, and we have x greater than or equal to -4. So if we write it formally, this is how we write it. For the range, we notice that as x becomes really large, the curve just goes on forever, and at the bottom part of the curve, y just keeps getting smaller and smaller and smaller. And then at the top parts, then y keeps getting larger and larger and larger. So that means y could be anything. So the range is the real number set. And when we write it the formal way, this is what it looks like. Finally, we're going to look at equations. If I give you the equation y equals to 5x subtract 8, how do we know if it's a function or not? And how do we tell the domain and range? Well, y equals to 5x subtract 8, we can tell that this is a linear relationship because this is y equals to mx plus b. So we know that it is always a one-to-one relation because each x will produce one and only one y value. For example, when x is 0, y is -8. When x is 1, y is -3. When x is 2, y is 2. So it's a one-to-one relation. Okay, I cannot substitute 0 into x and get two different values for y. It's impossible to do that. So therefore, it is a function. So the domain is everything. So x belongs to the real number set. Why? Because there's no restriction on the x-coordinate. X could be any number from -infinity all the way to +infinity. Because when we graph this relation, we get a straight line that extends at both ends. We do not get a maximum, we do not get a minimum. Okay, we do not stop at the right and we do not stop at the left. So there's no stopping anywhere. It's just a straight line that goes on forever. So therefore, the range is also everything. Okay, so y belongs to the real number set. Let's look at our last example for this video. For the relation y equals to -x squared subtract 4, we want to determine if it is a function or not. When we look at the equation, we notice that it is a quadratic relation because we have x squared. And this is written in the vertex form. So therefore, it is a function. Now, when we look at the domain, let's look at x. Is there any value of x that we cannot have? Well, we can substitute any value into x. Find its squared, and then find its negative, and then subtract 4, and we will always obtain a y value. So the domain belongs to the real number set. For the range, though, remember that our quadratic function has either a minimum or a maximum. And in this case, because A is negative, this is going to open down. And we know that the vertex is the point 0, negative 4, because H is 0 and K is negative 4. We also know that the vertex is the maximum point, so therefore the range is y belongs to the real number set and y has to be less than or equal to negative 4. That's all to this video. Thank you for watching.